Okay, here we are. Well, yes, here we are. So the first thing I want to talk about, and we talked about it already, is the fact that we want to talk about what a function is. We keep seeing this symbol f of x. And what the heck is f of x? Well, if it says it's f of x, then whatever graph we're looking at is a function. What is a function? Function is where every x value is paired to exactly one y value. Okay? So you need to write that down in your notes if you're not with us today. And then we looked at some examples of what constitutes a function. And then I said, well, what if you, real quickly, wanted to buy a longboard? And I said, okay, if you want to buy a longboard, and you saw two prices on it. You saw a price for 150 and a price for 200. It wouldn't make any sense. So the definition of function says where every x value is paired to only one y value. So if this longboard had two prices, it wouldn't be a function. It doesn't make any sense. Okay? So then we talked about how you could do this thing called the vertical line test. And the vertical line test, is where if you can draw a vertical line straight down anywhere on a graph and it touches the graph in more than one place, it is not a function. So then we looked at some examples, and this one definitely is a function, right? This one's a function, okay? This one would be a function because every x has exactly one y, is a function. But this one here is not. You can see that you've got 2 points for one x value, not a function, okay? Then we looked at this one. This is a little bit tricky, but that's an open circle, so technically this would be because it passes through that, doesn't touch it, but then touches this one. So that one is a function, okay? Now, let's keep talking about functions. So what we do is when you see, and we're going to go to page 29 in our journal, okay? So everybody go to page 29. What we see on page 29 is this symbol, f of x, which basically is y, right? And then if we look at the absolute value graph, which the absolute value graph we looked at the other day looks like that. That's a function, right? That's definitely a function. That's an absolute value graph. And today we're going to continue talking about transformations, okay? So if we take a look on page 29 and we get a negative in front, then what happens is that it makes it upside down. So if you have a negative f of x, then it is going to be a reflection over the x-axis, okay? Because f of x and y are the same thing, that's what we've talked about, so the same thing as a negative y. Well, if all my y values become negative, they would go down here. If all my y values become negative, then they would, boom, right down there. So negative f of x is like a negative y, which is a reflection over the x-axis, okay? We talked about these a little bit, but more importantly, I want to talk about this one right here. And I like to call it the dance. But any kind of change on the inside is always a horizontal shift, but it's going to be the opposite direction. And that's why they use a negative here, because by doing the x subtract h in math, negative to x, it means opposite. It really does, okay? How am I doing? Okay, so let me shift the page. I'm going to go to page 30. If I go to page 30, they say it's a horizontal translation. We knew that, I just told you, but it's the opposite direction, right? It is a horizontal translation, but it's the opposite direction. Okay. Now, anytime you do a horizontal, it's always the opposite. So if we took a look at f of x minus h plus k, then we're going to have a horizontal and this would give me a vertical shift. So anything on the inside changes it horizontally, opposite. Anything on the outside just makes it go up or down. This is just like an up or a down. Okay? All right, cool. Emma and Ada are sitting there because they already know this, don't you, right? Heck yeah. Okay, now, let me shift to page 31. So on page 31, we talked about this one. If the negative is here, it's like a negative y. It's a reflection over the y-axis. We have that one. We talked about that one as well, right? Oh, sorry, you guys. There it is. That's like a negative y, right? That's like a negative y, which means it's a shift over the reflection over the x-axis. But if the negative's on the inside, then all of the x's become negative. So your x's become negative, right? If your x's become negative, these x's then shift over here. So if the negative's on the inside on the x, like a negative x, then what happens is all your x values here shift over the y-axis. So this is a reflection over the y-axis, okay? Now, anything that is on the inside is always the opposite, always. And it's just tricky. But if we had a times f of x, a is some number, as an example, I want to give you an example, right? Like 3 times f of x, okay? I'll give you an example, okay? That makes it 3 times as tall, okay? Makes it 3 times as tall. It's a vertical stretch, okay? So this would be called a vertical stretch. 3 times as tall. But on the inside, it gets goofy, because remember, everything on the inside makes it so that it changes it. But in this case, if I have a number like f of 3x, okay, it does not make it 3 times as wide, but just the opposite, okay? It's going to make it 1/3 as wide, okay? And they kind of give that to you here. It's going to make it 1/3 as wide. We will not do a lot of these because these are pretty tricky. We'll do a lot of these in pre-calculus because I like to save the tricky ones for pre-calculus, okay? All right, now, what about our notes? Well, let's take a look at our notes. Let's do some of these, okay? So example 1. My notes today, it's 1/20/21, okay? So what's going on? What's it asking? So it says given f of x equals absolute value of x. Okay, I know what that graph looks like. Okay, real quickly, just going to do a real quick sketch. I know that this graph looks like this. Let me get my pen out. I know this graph looks something like this, right? It's the V. And what we're going to do is we're going to translate it. We're going to move it. So we're going to take and then sketch f of x plus 3 minus 2. So we're going to take this graph, which is my absolute value graph, right? F of x. We're going to take this graph and we're going to shift it. So what we're going to do is the opposite of the inside. So we're going to change and move my vertex to -3, -2, right? Opposite of the inside. So we're going to take this graph and just move it to -3. 1, 2, 3, 1, 2. So I'll take my original function, which is my absolute value graph, and I just move it. How's that? Thumbs up? Pretty easy? Okay. Okay, let's look at number 2. So number 2, my parent function, my original graph, is x. Well, that's going to be like a straight line, linear. It's going to look like this, right? Because it's got a plus 0, up 1 over 1. That's the parent function. I think even if we look at our notes from the day before, I think it's page 21. Nope, it's not page 21. Sorry, page 26. 25. Fine, found it, okay. There it is, right? Fx equals x. It's that one right there. So I just graphed my parent function. And in this one, we're going to move our graph back. If it's got a negative 1, we're going to do the opposite. So we're going to go to the right 1, because we're going to do the opposite, right? We're going to do the opposite of the inside. And then we're going to take it and move it up 5. So I got to move the whole entire graph, but I'm going to pick just a point to pick it up and move it right. So I'll just take the origin. It's right there. So I'm going to take that point. I'm going to move it to the right 1 and up 1, 2, 3, 4, 5. How's that? Okay, let's look at, am I going too fast or am I okay? All right, let's look at number 3. So first of all, I want to see what the original graph is. I know it's a parabola, and the original graph looks like this. It's a parabola, right? I know it's 0 squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, right? So this is my original graph. And what I want to do with this particular parabola is I want to take it up 4, right? I'm going to take it up 4. So I'm going to take this graph and move it up 4. But then I've got to also make it upside down, right? Because of the negative. And then finally this 2 is going to give it a vertical stretch. So I'm going to stretch it by 2. So I'm going to make a vertical stretch. So to make this easier for everybody, I'm going to do this in 2 steps. Okay, I'll do the vertical stretch at the end. Okay. So I'm going to take it up 4. 1, 2, 3, 4. Okay, I'm going to do that first. I'm going to take this graph, bring it up 4. And I'm going to make it upside down. So I know that I'm going to go 1 over 1. I'm going to go over 1, and 1 times 1 is 1, but upside down. For my vertex, I go 1, 2, 2 times 2, 2 squared is 4. 1, 2, 3, 4, right? For my vertex, I'll go over 1, 2, 3. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I also know parabola is symmetrical, so I know I'd have a point here, a point here, and a point here. Okay? Now, I'm not done, because what I haven't done is I haven't stretched it yet. So let me do a stretch. So it's got to be twice, I got to stretch it. I make it twice as long. So I'm going to take and make this point go to here. So instead of going down 1, it goes down 2. Does that make sense? So this point here went down 4, but I'm going to make it go down 8. So I'm going to go 4, 5, 6, 7, 8. This went 9. I don't think I'm going to get 18, but it's way down there. Okay, so, and of course it's symmetrical. So my graph, does it look taller, skinnier? It does. I hope. Hopefully it does, doesn't it? So I did 3 things. I moved it up 4. I made it upside down, and I stretched it, okay? How am I doing? Okay. All right, and all right. Oh darn, it bled through. I'll have to grab a different sheet of paper. Here we go. Yeah, that's right, bled through. Okay, number 4. Now the square root graph. What does that look like? Well, let me show you what a square root graph looks like. First of all, before we do a square root graph, you cannot take the square root of a negative number. Everybody agree with that? We talked about that last year, last semester. You can't do the square root of a negative number. Impossible. Nope, can't do that, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Please write that down, okay? Please write that down. 1, 2, 3. Okay, so the parent function, the standard square root graph, looks like this. All right, you ready? Hunter, what's the square root of 0?
0.
Easy. So add 0, we get 0, right? Okay. Callan, what's the square root of 1? Yeah, right? Now the square root of 2 is about a 1.41, and the square root of 3 is about a 1.73, blah, blah, blah. Those are ugly numbers, right? Let me show you my calculator, right? So we'd prefer to avoid ugly numbers. Let's see. Do I have a calculator around here? I should. Got a whole drawer full of calculators, and I can't find a calculator, huh? Oh, here we go. So we could put these numbers in. Like, for example, we could go square root of 2, but it's just ugly numbers, right? We could go the square root of 3. But I'd rather go straight to 4, okay? Right? So, Emma, what's the square root of 4? 2, right? So I'm going to put that number in, because I know the other numbers are in between. Does that make sense? The other number's there. Ada, what's the square root of 9?
3.
There you go. And there's no negatives, so my graph just looks like that. That's the parent function, okay? Of the square graph. So then, if I want to take and make a new graph, this one we want to make it a negative f of x, okay? So if it's a negative x, that means that it's going to be a reflection over the y-axis. So it's going to be a reflection over y-axis. Okay, so we're just going to take and graph it this direction, that's all. So, -1, -4, -9's there. There it is. Okay. Shift it up. X cubed. What does that graph look like? Well, let's take a look, okay? Let's look at the parent function. Okay. 1, 2, -1, -2. We're going to cube these numbers. And I'm not even going to put 3 down because 3 cubes 27. Okay, 3 cubed is 27, so it's way off my graph, right? And I will put these numbers in there. They'll all go maybe a 5, 10, I'll go -5 and a -10, okay? So let's look at the parent function. What does the parent function look like, okay? So, what's 0 cubed? What's 0 times 0 times 0? Antonio? Tony, what's 0 times 0 times 0?
0.
Good, that's easy, right? Okay, you guys, what's 1 times 1 times 1? 1 cubed is 1, so I'll put a point there. Now, what's 2 times 2 times 2? Don't say 6. What's 2 times 2 times 2? 8. So I'm going to put a point up at 8. All right, now, what's a negative times a negative times a negative? What's a negative times a negative times a negative? It's a negative, right? So what's -1 times -1 times -1? -1. What's -2 times -2 times -2? -8. So my x cubed graph, the parent function, looks like this. It's got kind of like a curvy look to it, right? That's my parent function. So let's take this parent function and we're going to move it. We're going to go to, remember, the opposite. So we're going to move it to the right, 3, and up 2. Well, I got to take the whole thing, so for me, it's just easier to move this point right here. It's not really a vertex, it's called an inflection point. I'm going to take this point, I'm going to move it to the right 3, and then up 2. I take this point, the inflection point, and I'm going to move it to the right 3 and up 2, because the opposite of the inside, right? And then I'm going to do my same graph. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, last graph. So if this is a cube, then the cube root looks kind of like a cube graph, except for it's going to be kind of sideways. I'll show you. We'll do it, okay? So a cube root is going to be kind of sideways, okay? So when I do a cube root, though, I need good numbers. Like I need 1, 2, 3, 4, 5, 6, 7, 8, okay? Because I know what the cube root of 8. The cube root of 8 is 2, right? The cube root of 1 is 1. I'm going to have a negative 1, 2, 3, 4, 5, 6, 7, 8, and negative 8, okay? So, first of all, I'm going to put both graphs on here. I'll put the parent function first, okay? So the parent function looks like this. So the cube root is 0. What times what makes 0? Obviously 0. Cube root of 1 is got to be 1, because 1 times 1 times 1, right? Now the next one is the cube root of 8. So what times what makes 8? What? Yeah, 2, right? So I got a cube root of 8 is 2. Cube root of 8 is 2, okay? So then the cube root of negative 1 is negative 1, because negative 1 times negative 1 times negative 1 is negative 1. And the cube root of a negative 8 is negative 2. So this graph looks like this. And you can put this on Desmos or on your calculator if you don't quite remember how it looks like. But that's the parent. That's my parent function. So now, let's take this graph and let's move it. Let's translate it. So I'm going to translate it to the left 2 because it's the opposite. And then let's go down 5. So the easiest thing for me, again, is to move the inflection point. I'm going to move the whole graph, right? But I'll just move the inflection point. So I'll go to the left 2, so I'll go 1, 2, and I'll go down 1, 2, 3, 4, 5. So it's off my graph. I probably should have made a better graph. Guess I'm too lazy to do that, huh? And then it should look like this. 2, 1, 2, 3, 4, 5. 6. You can move these, right? You can move these points if you wanted to, but it should look like that. Okay. There it is. Okay, and I'm going to stop my recording. It's a long one, huh?